impulse?
Nerve impulse? Bakit? Is that... No! I have no idea.
Nerve impulse? That's easy. The process starts with a negative charge inside the cell and a positive charge outside the cell. Sodium gates open and rush inside the cell. The transmission of action potential occurs. The sodium gates closes, while the potassium inside goes out of the cell. The cell returns to its resting state with the sodium-potassium pump. Get it? No? plasma membrane is polarized. Take note, this classroom will serve as the representation of the inside of the cell. The door will represent the sodium and potassium gate, and the halls will represent the outside of the cell. The positive ion inside the cell are the potassium ions. The major positive ions outside the cell are the sodium ions. There are fewer positive ions that are sitting on the inner face of the neuron's plasma membrane that gives it negative charge. It is represented by our two introverts that are timid and negative in personality, just like the negative charge inside the cell. Thus, it gives a more positive charge. They are represented by our three extroverts with a very spontaneous, outgoing, and positive personality, just like our positive charge outside the cell. As long as the inside remains more negative than the outside, the neuron will stay inactive. Take note, the inside of the cell has a charge of negative 90 millivolts during its resting state. Before undergoing the next process, it must first reach a stage called threshold potential. It must reach a charge of negative 55 millivolts in order for the next process to proceed. When a stimulus is received by the neuron, the sodium gates open and the sodium ions rush into the cell. Normally, sodium ions cannot diffuse through the plasma membrane to any great extent. But when the neuron is adequately stimulated, the gates of the sodium channels in the membrane open. Because sodium is in much higher concentration outside the cell, they diffuse quickly into the neuron. The neuron is now depolarized, which means there has been a change in the polarity of the neuron's membrane. It is now at its graded potential, wherein the inside of the cell is now more positive and the outside of the cell is less positive. If the stimulus is strong enough, depolarization causes membrane polarity to be completely reversed, as what I have defined in the graded potential. Thus, an action is initiated. An action potential is an all or none response. It is either propagated, in other words, conducted, or it doesn't happen at all. Before the propagation of the action potential, depolarization of the first membrane patch causes permeability changes in the adjacent membrane, and the events described in the depolarization are repeated. Thus, the action potential propagates rapidly along the length of the membrane. Almost immediately after the sodium ions rush into the neuron, the membrane permeability changes, becoming impermeable to sodium ions. Thus, the sodium gates close. But the membrane becomes permeable to potassium ions. Thus, it is allowed to diffuse out of the neuron into the tissue fluid. This process is called repolarization. It is a process that restores the electrical conditions at the membrane to the polarized, or resting state by the outflow of positive ions. Before reaching its resting state, an undershoot occurs that makes the charge more negative. The potassium gates open slowly and closes slowly. This is called hyperpolarization. Finally, the initial concentrations of the sodium and potassium ions inside and outside the neuron are restored by activation of the sodium-potassium pump. 3 sodium ions leave the inside of the cell,